Okay, today we're going to look at multiplying radicals. So please write down your essential question and get ready for your notes. Okay, so in this lesson, we're going to talk about the product property of radicals. And really, it's just important to understand why we can do what we do. So the product property is just saying that if we have two radicals, each with a different radicand, that you can actually put them together underneath the same radical. Here's an example with numbers because I think it makes a little more sense. The square root of 2 times the square root of 3. These are both radicands. And so this property is telling us that we can just take those two radicands and we can actually multiply them together. They do not have to be like radicals in order to multiply them. So this would actually be the square root of 6. Everything's simplified, nothing else we need to do there. Okay, so let's look at some examples. And as we look at all of these examples, I want you to keep in mind that sometimes there's more than one way that you can approach this. So if you have a different way in your mind, then that could be okay. Here we have the square root of 3 times the square root of 15. I want you to notice that neither one of these radicands has a perfect square inside of it. So neither one of these can be simplified more. So if I multiply them together, 3 times 15 is 45. But now I need to see if I have any perfect squares in there. Well, I hope that you're realizing that this has a perfect square of 9 within it. And so the square root of 9 is 3. And so this would be 3, the square root of 5. Okay, that's it. Really simple, right? Okay, here's another one. This one's a little bit different because we have both coefficients and we have radicals. So something I want you to keep in mind is that coefficients get multiplied together and the radicals get multiplied together. And I'm going to say radicands because that's what we're going to focus on. And the radicands multiply together. Remember, they don't have to be like radicals to multiply. So when I put these together, I'm going to put together 7 times 3, which is 21. And then I'm going to put together 6 and 10, which would be the square root of 60. But now I need to see, does 60 have any perfect squares in it? It sure does. It has 4 and 15. So the square root of 4 is 2, and I'm just writing that so we understand why and what we're doing. And so 21 times 2 would be 42. So in simplest radical form, this would be 42, the square root of 15. Okay, let's look at another one. Okay, this one has a monomial times a binomial, and we have parentheses. So I hope everyone's first instinct here is, hey, we've got to distribute. Doesn't matter that 2 doesn't have a radical with it. I'm just going to say negative 3 times 2, which is negative 6, and then we're just going to tack on the square root of 3. And then we're going to distribute it to the square root of 6. So again, nothing here to multiply with the negative 3, so it's just going to be minus 3, the square root of 18. Now I need to check both of these radicals. 3 already simplified, so that stays 6 the square root of 3. 18 would break it down to 9 times 2. So the square root of 9 is 3. So that's kind of what I'm doing there. So this is going to be minus 9, the square root of 2. Now double check. We can't combine these. We're adding and subtracting now. These are not like radicals, and so that would be it. That would be simplest form. Okay. Let's look at one more. Okay, so I want you to look at this one. Think about it for a second. You may be noticing that 75 can possibly be simplified. So if you wanted, you could simplify that radical first. Same thing here, my x cubes, but it also might be easier just to go ahead and multiply it together and then break it down. 75 times 2 is 150. My x's, ooh, we got to go back to exponent rules. Remember, we're going to add the exponents, x to the 4th, and then y. Okay, so let's talk about how this breaks down. 150, 25 is going to go into that. That would be 25 times 6. X to the 4th is going to be a perfect square, and we have y. Okay, so the square root of 25 is 5. The 6 is going to stay where it is. The square root of x to the 4th is x squared. We have 2 pairs of x's, and then a y left over. Okay, so there we go. What I want you to do now is I want you to stop the video, and I want you to see if you can do the next 2 problems on your own, and then turn the video back on and check your answers. Okay, so right here, when we distribute, we would get 7, the square root of 18, plus 6, the square root of 6. 18, though, breaks down to 9 times 2, so that comes out as a 3. And so we have 21, the square root of 2, plus 6, the square root of 6. So did you get that? If you did, give yourself a pat on the back. Yay! Okay. Okay, here's another one. The next one you were to try. I'm going to go ahead and multiply together. There's nothing to put the 3 with, so it's just going to be 3 out front times the square root of 28 x squared y squared. 28 would break down to 4 times 7. These are already even exponents, so we're already good there. The square root of 4 is 2, so 2 times 3 is 6. That leaves the 7 underneath. The x squared, that's a perfect square. We have 1 pair of x's and 1 pair of y's. So 6xy, the square root of 7.